So, this week, we will continue on our log journey, and then we haven't decided yet if we're going to have, it's going to be a formative this week, but we haven't decided if it's going to be Thursday or Friday yet. We're still debating and talking and figuring stuff out. All really depends on how well Wednesday goes for class, because Wednesday's kind of a big day for logs. Yep. So if you haven't memorized the changing of the forms, you need to get that memorized, because that is going to make logs be much, much easier for you. Just as a side note, we are not going to take a summative on logs, but there will be, I think it's 3 or 4 questions on your final from logs. Okay. So it does make up a significant chunk of your final. Okay. 15 questions. All short answers. Yeah. Well, like like fill in, like not scan, not multiple choice. Yeah. Okay. Okay. Let's do this. Let's solve. So how we're going to go about solving is, if we've got an exponential, we're going to put it in logarithmic form to solve it. If we've got a logarithmic, we're going to put it in exponential to solve it. That's why this is so important. Why you should just flat out memorize. Where should it also be put?
In our supplemental note.
On your supplemental note sheet, because that you can use on the final also. Okay? So definitely want to put this on that too. Yep. Okay? So the very first thing that you need to do, so if we're solving an exponential equation, the very first thing that you have to do is you need to isolate the exponent term. Okay. So the term with the exponent on it, that you need to get all by itself on one side of your equation. Okay. So in this particular case, that term is this 3 to the x power. So that purple box needs to be all by its lonesome on whichever side you want it. Okay. So what I would do here is I would then add 4 to both sides. That gives me 3 to the x power equals 10. Okay. Then, once you have that term isolated, then you are going to switch from exponential to logarithmic. These steps are going to be the same on the next slide when we start solving logarithmic equations. You're going to isolate the log term. Then you're going to switch forms with it. And then you're going to solve. So if I switch forms with it here, then I would have log. What is my base? No. 3 is my base. What is my argument? 10. And that equals my exponent. From there, then, you need to solve it. Is there an exponent that I can put onto 3 to get 10? No? What range should it be in? We don't know exactly because we're going to have to use a calculator, but where should our answer be in? What range of numbers should our answer be in? What do you got? Do we agree with between 3 and 4? Why 2 and 3? 3 squared is 9, right? And 3 cubed is 27. So it should be in between 2 and 3. I would agree with that. Should it be closer to 2 or closer to 3? Should be closer to 2. So if we use the change of base formula that we learned on Friday, we would do log of 10 divided by log of 3, or natural log of 10 divided by natural log of 3. And now this way, it gives us, we should know right away when we do this, when I get 2.095903274 on my calculator, because there's no way to be exact, right? Because it's not, because there's no one number that we can put on to 3 to get 10. So we know that we're in that right range. Okay? All right? So the answer here would be, we round to 3 decimal places, 2.096. Okay. It's going to be very beneficial for you to have the science for class. And so if you don't have one, there's some here, or you can get your phone to the side and down there too. Okay. Yeah. You try those 2 equations. So in number 1, first step, isolate the exponented term. Done? Not done? Done. Okay, all right? So then we need to switch forms with it. Okay? So if I switch forms with it, I get log base 4 of 54 equals 4x plus 2. Okay? Log base 4 of 54 is approximately 2.877443751. Then to solve it, what do I have to do?
Subtract 2.877443751 by 2.
So subtract 2 from both sides?
Yeah.
Yeah. Then what?
Then divide by both sides by 4.
Then divide both sides by 4. And that gives me 0.219360938. Now, what can we do to check this to make sure that we're right? Because, we got to be in between a certain range, and it's hard to do when you got extra stuff. Whoa. So how can I check to make sure that we're right? You can plug it back in for x, right? Okay. Now, if I plug the exact one in from my calculator, we should get exactly 54. If I plug the rounded one back into my calculator, 4 raised to the open parentheses, 4 times 0.2, not 0.1.219, close parentheses, then plus 2, I get 53.892. Okay? Not exactly 54, but I rounded down here, which is going to round everything back up there. If I use it still on my calculator, that's fine. It should get exactly that. over here, first thing I'd have to do is I'd have to add 3 to both sides. That gives me 2 e to the 2 minus 3x power equals 14. Then I would have to divide both sides by 2. That gives me e to the 2 minus 3x power equals 7. Now I've got it isolated, so I can switch forms with it. Log base e is natural log of 7 equals 2 minus 3x. The natural log of 7 is 1.945910149. Then I would subtract 2 from both sides. Then I would divide both sides by -3. And that gives me 0.0180299. Questions, comments, concerns, clarifications on that? If I go that one times -3, and I go 2 minus that answer gives me that, and I take that to the power of e, gives me that, and I multiply that by 2, yeah, close enough, I think, right? Yeah.
And then you put your number. Close the
Oops, because then I got to subtract 3.
Yeah.
Yeah.
Wait, what do you mean base? Oh, that's what the change base formula is. You can't put it in like that. You have to put in log whatever the other number
Yep.
is over log base.
Alright, so then we've got logs that we got to solve too. So for solving single logs, same type of steps. Okay, so again, now this time we are going to isolate the log term. So here I would subtract 3. Once we've isolated the log term, then again, we're going to switch forms. What is the base in this one? Nope. Nope. The base. 10. Exponent? 2. Argument. Then we're going to solve. Ten squared. Add 3. And then here, it's really important, because now we're dealing with logs, that we need to check it. What were the two like things from Friday that makes logs not work? Or what can't we have in a log?
Negative. B cannot equal 1 or 0.
What?
Huh?
What can equal 1 or 0?
Base.
Okay. There was one more thing too. The base can't equal 1, it can't equal 0, and it can't
Be negative.
be negative. Okay. What was the other thing? That was all of the conditions on the base. There was one more thing too. From Friday. In your notes. What? Not growth and decay. Nope, that's not going to affect it. That's exponential. What? Argument has to be positive. Argument has to be positive. So the base has to be positive, but it can't be 0 or 1. And the argument has to be positive also. Okay? Alright? So if I do that, if I plug this back in, 103 minus 3. Plugging it back into my original equation. 103 minus 3. Don't even think about pulling out a calculator for this. What do you got? 100. Okay? Log base 10 of 100. What exponent do I put on 10 to get 100? 2. 2 plus 3. Works out. Yeah? You try that one. Isolated. So I can switch forms with it. 4 to the 6th power equals 3x. 4 to the 6th power is 4,096. 4 plus 0 is 4. 4 plus 9 is 13. 13 plus 6 is 19. So it is not divisible by 3. So my answer then is just 4,096 over 3. Mia, did you know that trick? If you add up all the digits in a number and they're divisible by 3, then the number is divisible by 3. So 4 plus 6 is 10, plus 9 is 19, plus 0 is still 19. 19 is not divisible by 3, so 4,096 is not divisible by 3. Little trick. 4,096 divided by 3 times 3 is 4,096. The exponent of that, put up 4, 4,096. 6 is equal to 6. Checks out. Love it. Okay? Now, the next one that we have is solving 2 logs. And we're going to go in log equals log case. So nothing else Okay? So we got no other terms going on here with this. We just have log equals log. Okay? This also works if you have exponential equals exponential. Okay? Okay? So the first thing that you have to look for is you have to look for, and you need to see if the bases are the same. If those two are the same, then the two arguments are equal. So this just boils down to 2 minus x equals 5x. If provided the bases are the same. If the bases are not the same, then it becomes a whole world of ooh, yee, ooh, stuff that we're not going to do. Yeah. Okay. It's like 17th layer of this all that. Okay? Alright? 2 minus 1/3 is 5/3. 1/3 times 5 is 5/3. Log base 7 of 5/3 is equal to log base 7 of 5/3. Now, if you have exponential equals exponential, you also have to have the same base. Do we have the same base here? We don't, but 4 can be written as 2 squared. Power to a power, thinking back to all of our exponent rules, that means I'm going to multiply those two. So that means I've got 2 to the 6x power equals 2 to the 7 minus x power. Now I have the same base, and so now my exponent has to equal my exponent, because I have the same base. It's all about having the same base. What's up? I don't know what neutral log is. Common log? Natural log? Natural log? Same thing. Same thing. 3 times 1 is 3. 4 cubed is 64. 7 minus 1 is 6. 2 to the 6th power is 64. 64 equals 64. So x. No? Here's one of those. Try this one. 2/7 times 2 is 4/7. 5 minus 4/7 would be 31/7. 10/7 plus 3 would be 31/7. Checks out. Yeah. One last one to do. For that.
This is code.
Talk to me, Paco. What can't be a negative?
The base.
The base or the argument can't be negative, right? Okay, so if I immediately put this one back into here, I get log base 2 of -2 minus 8, which is log base 2 of -10. And that argument has to be positive, so there is the fail, so there is the fail, so therefore it is no solution. Now, on Wednesday, we'll get to ones that have multiple answers. And multiple x values will make these work. One or both of them might fail. If both fail, then it's no solution. If one fails, then just the other one is the solution. Okay? You should have picked up a pink homework sheet this week, for this week. That will be due on Friday. Okay?